Agentic Commerce Protocol defines how AI agents discover, negotiate, and settle commercial transactions without a human authorizing each step. That sentence sounds complete. It isn't. The discovery layer works. The negotiation layer is maturing fast. The settlement layer, the part where money actually moves, is broken in a way that no current protocol addresses. This video proves that claim with specific architecture, specific numbers, and specific failure modes. By the end, you will know exactly where the gap is, why it exists, and what infrastructure closes it. Here is what we cover: what Agentic Commerce Protocol actually defines and what it deliberately leaves out, how the agent payment stack is structured in 2026, the 4 specific failure modes that break autonomous payment at scale, why cross-border is where the constraint becomes most visible, what a properly built agent wallet looks like at the infrastructure level, the one architectural decision that determines whether your agent deployment is actually autonomous. If you build with AI agents, run agent infrastructure, or operate in fintech, this is the architecture briefing you need. Agentic commerce means AI agents complete full commercial transactions autonomously: discovery, negotiation, contract, and final settlement, with no human countersigning each step. The word protocol here is doing specific work. A protocol defines message format, handshake sequence, and authorization flow between parties. What it does not define is where the funds sit, how they settle, or what rails carry the transfer. Let's be concrete. The Agentic Commerce Protocol, ACP, as currently scoped by the major players, including MasterCard's Agentic Commerce Initiative and the AP2 Agent Payments Specification, covers agent identity verification between transacting parties, intent declaration, what the agent wants to buy, at what price, authorization, handshake, does the agent have permission to transact, transaction record, and audit trail. None of those 4 layers touch money movement. ACP tells 2 agents how to agree to a transaction. It does not tell the money where to go or how fast to get there. This is not a criticism of the protocol authors. It is a deliberate scope decision. The problem is that the market has started treating ACP as a complete solution. It is the negotiation stack. The settlement stack is a separate problem entirely. Here is the analogy. TCP/IP defines how data packets route across the internet. It says nothing about what the data contains or what application processes it. ACP is the TCP/IP of agent commerce. The wallet is the application layer. And in 2026, nobody has shipped the application layer at production scale. Let me show you the actual architecture as it exists today, layer by layer. Layer 1, the reasoning layer. This is the model: GPT-4o, Claude 3.5 Sonnet, Gemini 1.5 Pro. The reasoning layer receives context, evaluates options, and produces a decision. It is commercially mature. Costs have dropped by roughly 85% in 18 months. This layer works. Layer 2, the orchestration layer. This is the agent framework: LangChain, AutoGen, CrewAI, custom orchestration. The orchestration layer sequences tasks, manages tool calls, and maintains state across a workflow. Also commercially mature for most use cases. This layer mostly works. Layer 3, the action layer. This is where agents take real-world actions: browse, write, search, generate, call APIs. The action layer is immature in places. Computer use agents still fail on complex UIs, but it is functional for structured tasks. This layer works for structured tasks. Layer 4, the payment layer. This is where an agent needs to move money, authorize a charge, transfer funds, pay an invoice, settle a cross-border wire. This layer is not commercially mature. In most deployments, it either does not exist or it is replaced by a human approval step. The gap is between layer 3 and layer 4. The action layer can call a payment API. The payment API requires credentials the agent was never issued, a human login session the agent cannot maintain, or a bank account that requires human identity verification to open. Here is the specific failure. An agent running a supplier procurement workflow can execute 61 sequential tasks without human input: evaluate RFQs, draft contracts, initiate vendor onboarding. The 60-second task is transfer $3,400 to a supplier account. The agent cannot complete task 62 without a human who holds the payment credentials stepping in. All 61 previous tasks were autonomous. Task 62 is not. Every agent deployment in 2026 has a task 62. The question is where it sits in the workflow. I am going to walk through the 4 specific ways autonomous payment breaks. These are not theoretical. These are the failure modes I see across deployed agent systems. Failure mode 1. Identity mismatch. Payment rails require identity. A bank account is tied to a legal entity, a person or a company. An AI agent is neither. When an agent attempts to initiate a payment, the rail asks, "Who is the payer?" The agent has no answer that the rail accepts. Workarounds. Developers proxy payments through a human-owned account, hardcode credentials, or use a shared team card. All 3 workarounds break at scale. Shared credentials create audit failures, hard-coded credentials create security exposure, and proxied accounts require human availability. Failure mode 2. Spending authority. Without a principal, traditional payment systems assume a human principal who authorized the spend. Credit cards have cardholders. ACH transfers have account holders. Wire transfers have signatories. Every legacy payment rail was designed with a human at the top of the authorization chain. An autonomous agent needs to spend money on behalf of a business outcome, not a specific human. No legacy rail supports this natively. The closest approximation is a corporate card with pre-approved limits, but even those require a human to set the limit for each vendor individually. Failure mode 3. Settlement speed mismatch. Agent decision loops run in seconds. ACH settles in 2 to 3 business days. Swift settles in 3 to 5 business days. This is not just slow. It is architecturally incompatible with agent workflows. Consider an agent managing a real-time content licensing marketplace. The agent negotiates a license at 2:14 p.m., generates the deliverable at 2:16 p.m., and needs to release payment to the creator upon delivery confirmation at 2:17 p.m. ACH cannot settle that payment for 48 hours. By the time settlement completes, the agent has moved through 200 more decisions. The payment record is now decoupled from the workflow record. Reconciliation becomes manual. Stablecoin settlement on Hedera completes in 3 to 5 seconds. That is the only rail that matches agent decision speed. Failure mode. 4. Multi-currency without local liquidity. A global agent deployment, one handling supplier payments across Brazil, Nigeria, Vietnam, and Poland, must transact in local currencies: BRL, NGN, VND, PLN. Legacy cross-border rails convert at bank rates, apply transfer fees, and take days. An agent moving $500 equivalent to a Nigerian supplier via Swift loses $20 to $40 in fees and waits 3 business days. More critically, most agent payment infrastructure assumes the agent transacts in USD and operates within a Stripe-compatible country. That assumption covers roughly 35% of global GDP. The other 65% is not served by the dominant agent payment stack. This is the structural gap the global majority clause identifies. Every agent wallet built on Stripe's infrastructure leaves the majority of the world's developers and operators unserved by design. Cross-border payments are where every failure mode compounds simultaneously. Consider the specific architecture of a traditional cross-border payment. 1. Payer bank initiates SWIFT message. 2. Message routes through correspondent bank. 1. Typically in the payer's country. 3. Routes through correspondent bank. 2. Typically a major global clearing bank. 4. Routes through correspondent bank. 3. Typically in the recipient's country. 5. Recipient bank credits the account. 5 nodes. Each node adds latency. Each node takes a fee. The correspondent banking chain on a $1,000 transfer from the US to Nigeria typically costs $35 to $65 and takes 3 to 5 business days. Now run that through an agent workflow. The agent initiates payment at node 1. The agent cannot query node 2's status because SWIFT messages are not real-time queryable. The agent has no confirmation signal until the recipient bank credits, 3 to 5 days later. The agent's workflow has to suspend for 3 to 5 days, or the human operator has to manually confirm and restart. On-chain stablecoin settlement removes all 5 nodes. There is one transaction on a shared ledger. Both parties can query status in real time. Settlement completes in seconds. Fees are fractions of a cent. The architectural difference is not incremental. It is categorical. The correspondent banking chain is not improvable into something an agent can use. It needs to be replaced. BananaCrystal's model demonstrates this. Fund a wallet with USDC, convert to a local stablecoin, USDB or equivalent, swap for any target token, withdraw to the recipient's local wallet. The entire chain runs in seconds, operates programmatically, and does not require a human to be present at any step. That is what agent-compatible cross-border infrastructure actually looks like. Let me spec the actual requirements for a wallet that a production agent deployment can use without human intervention. Requirement 1. Programmable authorization. The wallet must accept spending rules as code, not as manual approvals. An agent should be able to declare authorize payments to vendors on this approved list, up to $5,000 per transaction for categories tagged OPEX. The wallet enforces those rules on every transaction the agent initiates, without human review of each one. Requirement 2. Agent native identity. The wallet must be associated with an agent identity, not a human identity. This means the agent has a cryptographic key pair. The wallet maps to that key pair and authorization flows from the agent's key, not from a human's login session. Requirement 3. Multi-currency at the infrastructure layer. The wallet must hold and transact in multiple currencies natively, with conversion happening on-chain rather than through a bank. Local currency liquidity must be available without routing through a human FX desk. Requirement 4. Settlement speed matching agent decision loops. Settlement must complete in seconds, not days. This is non-negotiable for any agent that needs to take subsequent actions contingent on payment confirmation. Requirement 5. Global reach without Stripe dependency. The wallet must operate in countries and currencies that Stripe does not support. This is the constraint that most agent wallet discussions ignore. A wallet that only works in the US, EU, Canada, and Australia is not a global agent wallet. It is a regional one with global marketing. No single legacy fintech provider meets all 5 requirements. The closest existing infrastructure is stablecoin native, programmable wallets built on fast settlement chains. Exactly the architecture BananaCrystal deploys. Every AI agent deployment in 2026 makes one architectural decision that determines whether the agent is actually autonomous or whether it is an expensive automation that still requires a human babysitter. That decision is, does the agent have a wallet it actually owns, not a wallet proxied through a human account, not hard-coded credentials that expire, not a shared team card that requires a human to reload it. A wallet with a cryptographic identity, programmable spend rules, multi-currency capability, and settlement that completes before the agent's next decision. If the answer is yes, the agent can operate end-to-end without human intervention. Discovery, negotiation, contract, payment, one continuous loop. If the answer is no, and for most deployments in 2026, the answer is no, the agent is autonomous up to the moment money needs to move. At that moment, the autonomy stops. A human steps in, approves the payment, and the agent resumes. This is not autonomous commerce, it is assisted automation with a human checkpoint at the one step that actually closes a transaction. The Agentic Commerce Protocol specs defines the negotiation layer correctly. It is the right architecture for agent-to-agent communication. The missing piece, the layer the spec deliberately defers, is the payment infrastructure. And deferring it is not a neutral decision. Every day that infrastructure doesn't exist, every agent deployment in the world is capped at 95% autonomy. The last 5% is a payment, and that 5% is the part that matters. Here is the summary. Agentic Commerce Protocol defines the negotiation layer. It does not define the settlement layer. The settlement layer is where all four failure modes live: identity mismatch, missing spending authority, settlement speed incompatibility, and multi-currency gaps outside the Stripe coverage zone. The evidence is in the numbers. $3,400 invoices that 61-step agent workflows cannot close. $30 to $60 SWIFT fees that erode the economics of global agent deployments. 4-second stablecoin settlement that matches agent decision loops. And 65% of global GDP that the dominant agent wallet stack simply does not reach. The fix is not a better model. The fix is infrastructure. A wallet the agent actually owns, with programmable authorization, agent native identity, multi-currency capability, and settlement speed that matches how agents actually work. If you want the full breakdown of how to architect this for your own agent deployment, subscribe to the Agent Payments research newsletter at agentpayments.substack.com. New briefings drop twice a week. And if you are building with agents and have hit the payment wall, drop a comment. I read every one. The specific failure modes your deployment surface are exactly what shapes the next briefings.